Welcome everyone to Science in Action. Today is February 16th, 2021. We're so excited to continue our weekly Science in Action speaker series, this time featuring our very own STEM Division's Dean, Carla Grandy, here to talk to us about her journey from geologist to dean. So without further ado, I'm really excited to have Carla here with us. I'll go ahead and turn it over to you.
Thanks, Brian. Let me share my screen really quickly. And it's nice to see all of you, and thank you for letting me come and talk with you today. So I kind of want to talk to you a little bit about my educational journey and kind of my career journey and some of the things that I've done to get to the place where I'm at now and kind of what that entails. And I guess the takeaway, which I'll reiterate later, but none of my education really prepared me for the job that I'm doing now. So I am a geologist by training, and now my job is the dean of the STEM division. And we'll talk more about what that means in a minute, but I guess the kind of the moral or the takeaway is that you never quite know where life is going to take you, and that you may change your career or your path throughout. So I am a coastal geologist by training. So that's my background. And I'm just going to give you a little bit of background in geology and kind of how I got to where I am. And then we'll talk some about my research and what I do now. So geologists, if we were in person, I would ask you what a geologist do. And most of you would probably tell me that they study rocks. And that is absolutely true. And it's only a very small part of what geologists do. So geologists do a lot more than that. And I'll talk about what I do, but most of my work is around water, studying water. This picture that I just put up here is some of my students on a field trip from an environmental monitoring class, monitoring the water quality in San Francisco. And it makes me really nervous now when I look at this picture. But that was a really fun class to teach, and the students really learned a lot and were able to study the environmental quality of some of the waters in San Francisco Bay. So geologists do that. They study water and water quality. They study the availability of water. They study the rock side of things, which is like the availability of resources, but also things like earthquakes and volcanoes. They study geologic hazards, so hurricanes, landslides, volcanoes, all of those things. Geospatial things like mapping and kind of like using GPS and using satellite imagery. And then they also do energy. And this is one of the areas, well, water, climate and climate change and energy are the areas where I really see there being a lot of growth and a lot of job opportunities in the near future. So right now we're, as a society, really reliant on coal and oil and natural gas, but we need to be able to move to alternative energies. And that's a place where there's a lot of things that we still need to figure out. And so there's a lot of room for people to figure out things and to have jobs. So that's a little background on geology. My path to STEM is, I'm from Texas originally. So this map in the bottom left-hand corner, you can see right where the Longhorn is here, that's where I'm from. And so that's about 5 hours drive to the closest ocean, and that's the Gulf of Mexico, which is not super exciting. It's nothing like the California coast. It's not quite as beautiful. But so that's where I grew up. It also has very uninteresting geology, which I'll talk about in a minute. But I really became interested in earth sciences through a concern around environmental issues. So there was a big Earth Day anniversary when I was in, I think it was probably middle school. And there was a lot of talk about some of the environmental issues that society was facing. And in Texas at that time, that was not really something that we talked about a lot. There wasn't a lot of recycling. There wasn't a lot of action around climate and climate change or understanding the environment. But that's when I really got interested in it. I also spent a lot of time outside as a kid. This picture on the bottom right is a lake near my house that I used to go to with my dad and go hiking. And so spent a lot of time outside. And then I also started going scuba diving with my parents when I was in middle school. And so kind of from all those experiences, I got really interested in oceanography and ocean science. And I got really interested in the environment and in protecting the environment and things that we were doing to negatively impact it, and then what we could do to make it better. So I went to my undergrad. I did my bachelor's in environmental geology in Texas, so Texas Christian University, which was right by my house. It was the same school that both of my parents had gone to, aunts and uncles had gone there, so it was very familiar to me. And as I said, the geology in Texas is not interesting. So this picture is the town that I'm from. But I put this map up here. So about 100 million years ago, when the climate was much warmer and the glaciers were melted, this whole part of the interior of North America was underwater. So here's Texas. It was totally underwater. And so what that means is that all of the rocks there are the remnants from the time when that area was underwater. So it's all limestone, which is just a white, kind of boring looking rock. So there was nothing really interesting to look at there. We had to get in the vans and drive to Oklahoma or someplace. Also not super interesting, but a little bit more interesting to kind of look at the geology. So as soon as I graduated from college, I was ready to get out of Texas. And so I went to Oregon State in Corvallis, Oregon, and got my master's in oceanography with a focus on marine resource management. So all of the stuff that I've kind of done looks at the science, but then how people are affecting the natural environment. So things that people are doing to either change it or to make it better or worse. So while I was there, I focused on engineering structures in the coastal zone. So looking at beaches and things that people build along beaches that impact the sediment supply. I worked for the Oregon State Parks Department, and that was a really cool opportunity. I got to drive around in a huge pickup truck and wear like a park ranger uniform and go visit all these different properties and walk on the beach and see what was happening there. And then I was really an intern mostly, but that opportunity allowed me to get a job after I finished there. So after I finished my master's, I moved to the Bay Area and I got a job at the California State Coastal Conservancy. The Coastal Conservancy, anytime you go, just about anytime you go to a park or a trail in the coastal area of California, you'll see the little symbol of the Coastal Conservancy. And so it's a state agency that gets money from the state, and then it uses that money to build trails or to do habitat restoration or to buy land to try and protect it. And so it's a really cool government agency. Most governments, no states don't have these. And so my first job out of grad school was mapping the California Coastal Trail. And I still to this day cannot understand how I ever quit that job because what I did was travel around the state. I got to fly all over and drive all over and hike for my work. And then I used GIS or Geographic Information Systems to map it and to look at areas where we had trails and areas where we don't. And then I also did some other habitat restoration things. So this picture is a picture of a dam in Southern California. The dam was built to store water, but it filled up with sediment. And so it was no longer storing water. And so we were able to take it down, you see the little scissors here, take down that dam to be able to restore habitat for the fish and frogs and other things that lived there. But my background as a geologist the role that I played was looking at what would happen to that sediment that's back there and how would that affect things downstream. So I did this job for a couple of years, but I really missed teaching. I had taught when I was at Oregon State. And so I decided to go back to school and get my PhD in earth science. So if any of you are looking at UC Santa Cruz as a place to transfer to eventually, feel free to reach out to me and I can tell you more about it. But I loved going to school there. It's a beautiful campus. And the work that I did was looking at coastal erosion in Southern California. And I'll talk more about that. But I guess one thing that I want to say is just for those of you who are listening, like I think I went to school for 10 years, which sounds like a long time. But the thing that's really cool in the sciences is that usually once you get past your bachelor's, schools will pay you to go to school. So you get paid to do research or you get paid to teach as the teaching assistant while you're earning your degree. And so I was able to get paid for the 6 years that I was in grad school and be able to get those degrees and then come out and get a job and not be in debt, which you are in a lot of other fields. So just a plug for the sciences there. So like I said, I studied coastal erosion and particularly in Southern California beaches. So I will talk a little bit about it. I realized as I was preparing for this talk that I was in grad school at UC Santa Cruz about 14 years ago. So it's been a while. And you'll see that from some of the diagrams that I'm going to show you. But this is work that was funded by the UC Marine Council and by the California Department of Boating and Waterways. And that's because beaches are a recreational resource. And so they were interested in how we can protect and preserve them. So the oceanside littoral cell. So a littoral cell is just a pocket of beaches. So this is an area that stretches about 55 miles from Orange County down to La Jolla in San Diego County. And so these are all of the rivers and streams that feed into it, the sea cliffs along here, and then the areas where the sediment goes offshore. So a littoral cell is just an area, it's kind of a confined area. Sand doesn't come from up here and go to these beaches. It just is created within here and moves along here. And then once it gets to the end, it goes offshore. It doesn't come around here. So it's kind of interesting for being able to study sediment transport. So this area, if you're not familiar with it, is very developed. There's these really beautiful sea cliffs, but almost all of the areas have houses built directly on them. So why do we care, first of all, is a question that you might be asking yourself, but why do we care about beaches? So like I said, down there, it's a recreational resource. These are numbers from 2003, but still a lot of money. So 14.8 million visitors and $5.3 billion in tourism revenue. San Diego is known for its beaches. It gets a lot of visitors there, which means a lot of their jobs are reliant on that tourism industry. And so they want to protect their beaches. Protecting the beaches also act as a buffer for anything that's built on top of them or behind them. So all the homes that are along there, the homes of the uber wealthy people who live along the coast, and then also any of the roads, or like in San Francisco, we have the wastewater treatment facility that's built right along the road. So protecting those types of resources, and also it's a habitat. So birds nest in the beach, other invertebrates and things live in the beach. And so preserving that preserves a place for them. So just understanding the study from a really simple perspective, beaches are made up of sand, and naturally the sand comes to the beach from a couple of different sources. Oops. So the first one is rivers. And so all of the rivers that flow across the land erode the land and bring sediment to the beach, and that's where it ultimately ends up. And then the other main source is beach erosion. So these sea cliffs that are behind the beach, those eventually erode, and all of that material goes onto the beach and makes beach sand. So those two things are really pretty easy to understand, pretty basic processes, and actually really easy to measure. I wished that I could find a picture of it today, and I couldn't find one, but the way that we measure sediment transport in rivers is just by taking a stick with like a bucket at the bottom of it, sticking it in the water. It catches sediment as it's moving through. You count how long it's catching it, and then you measure the sediment. So that varies a lot based on climate, and we'll talk about that in a second, but it's a really low tech, and a lot of these methods are really low tech and really simple to do. So we have a pretty good understanding of how much sediment comes from the rivers, and we have a pretty good understanding of how much comes from the sea cliffs. And we're able to do some of that by looking at historical aerial and satellite photos, where we can see how much the beaches have moved over time. They don't ever move forward, they just move back as they get eroded. So looking at that over the course of this study, you can see different sources of sediment. So a lot of years are really calm, and then all of a sudden you'll get a bunch of sediment. A lot of years are really calm, and then you'll get a bunch of sediment. So that was one piece of this, was understanding how that natural sediment production impacted the beach width. So the beach width is just the rivers and the sea cliffs, the sediment production from them. And then the waves kind of move it around. So they move it along the shore, and they move it off the shore, and then they usually move it back on. And so that's a pretty simple sediment budget. So the first part of this study was looking at old aerial photographs, and going back to 1945 through the early 2000s, and just measuring how much the beach changed from one year to the next. So again, pretty low tech, with the exception that these really old air photographs are kind of hard to work with, kind of hard to read, and there's a lot of error associated with them, and trying to rectify the image so that it's flat and you're comparing apples to apples. But pretty straightforward in terms of measuring that. And so the part that's more complicated is looking at the role that climate plays in all of this. So you hear a lot about climate and climate change, and some of that is natural and some of it is caused by humans. The thing that affects California beaches the most is a very natural process, and it's a process that's been going on for thousands of years that we know of from the geologic record. So El Nino and La Nina climate cycles. So what happens is normally the winds blow from east to west, and they push the water from east to west. The water builds up over here along the coast of Australia and Asia. But during an El Nino event, the wind stops, and so that water sloshes back across the ocean basin, and you can see that here. So this top image, and this is one of the 97-98 El Nino was one of the ones that had the greatest impact on Southern California, but also on Northern California beaches. So Pacifica, a lot of the buildings and apartment complexes and things that fell off into the ocean happened during this 97-98 storm. So this is one of the ones we talk about a lot. But what we're looking at in here is a cross section of the ocean basin. So the wind blows that water over here and it pools, and that affects the weather. You've got hot water, so you've got more evaporations, more storms, and that's why this area of the world has tropical rainforest, coral reefs, the things that normally like warm ocean water and lots of rain. The west coast of North and South America tend to be drier. They're more of desert type climates. We have, clear skies. We have a lot of productivity, a lot of biological productivity offshore because of that. But normally we don't have a lot of rain. So every 2 to 7 years or so, we have an El Nino event. And what happens is that the winds stop and this big pool of water sloshes back across the ocean basin. And it takes months for it to get all the way back across, but you can actually see it in satellite images. It's raised up a little bit higher than the rest of the ocean water, and it just kind of sloshes back across like water in a bathtub. And when it does, it totally reverses all of our climate. So when this warm water pools up on this side, here's that bulge of warm water. When it pools up over here, we get all of the evaporation that's associated with it. And so we get lots of rain and all of the geologic hazards that come with that. So if we look at this picture, this is again that 97, 98 storm. Here's that warm pool of water. During that time, the water is actually, the water level, the sea level is actually higher along the west coast because of thermal expansion. So even without there being more water, warm stuff takes up more space. So it expands and raises the sea level. So you've got higher than normal sea levels along the west coast, more evaporation and more storms. And so that leads to all the other geologic hazards. So landslides, coastal rivers, flooding, and then coastal erosion as well. So geologic hazards really bad if your house is built along the coast or if your house is built at the bottom of a hill. But this is when most of the sediment gets produced. So if we look at this, this is the El Nino Southern Oscillation Index. So it's showing you when we have El Nino events versus the other side of it, the more normal side, which is La Nina. So these red blobs are El Ninos. And so what I was able to see was that most of the sediment production that happened during these times. And then these blue blobs were the La Nina events. And so there was a lot less sediment produced during those times. The other piece of it, though, is that during El Ninos, when it's stormy, the waves also change. So this is looking at wave direction off of the coast of Southern California. And the waves come in at a different angle during El Nino events. Normally, they kind of bounce off of these islands and their energy gets dissipated. But during an El Nino, the direction of a wave approach changes and they're able to kind of sneak through. And so they end up impacting the coastline. The waves actually hit the coastline more directly, and so you get more sediment movement. So now there's a lot more sediment being produced because it's raining more, and so there's more water flowing through the rivers. There's more sediment being produced from sea cliffs because they're eroding more. So our two natural sources are increasing, but we've also got a lot more wave activity. So there's more erosion, more sediment being moved along. So that's kind of the second piece of the story. And this is just another look at that. This is the Pacific Decadal Oscillation. So we have these El Ninos and La Ninas, and those we've found out in the 90s tend to oscillate on about 30-year cycles. So there's about 30 years where we have mostly the cool phase or the La Nina phase. And then there's about 30 years where we have mostly the El Nino phase. So it kind of switches back and forth. So what this meant in this area was this time from the 1950s to the late 1970s, actually late 1940s to late 1970s. That was a time when a lot of people moved to Southern California and started buying property and building homes, and a lot of the infrastructure was built along the shoreline. That was a really calm period in terms of our coastal climate. And then beginning in the late 70s and through to kind of the mid 2000s, we switched to more of this El Nino type climate. So we started seeing a lot more activity, a lot more storminess, landslides, coastal erosion, and wave erosion. And so the narrative had been that coastal erosion was increasing, and we do expect to see that with climate change and with sea level rise. But looking at it in a little more depth, we were able to see that it wasn't really that it was changing, it was that it was oscillating back and forth, shifting back and forth with these climate cycles. So One other piece of that, which we kind of already talked about, but there's also a lot of things that people do. So people build dams, which stops the movement of sediment through streams. People build seawalls, which stops the coastal erosion and so cuts off that sediment source. And then particularly in Southern California, they nourish the beach. They dredge sand from offshore or from upstream, and they dump it on the beaches. So all of those things combined, and I'm speeding up now because I have more stuff I want to talk about. I'm afraid I'm going to run out of time. But all of those things combined, so this is a model of along shore, so going from north to south, and then from the various years of the study, starting from the mid 1940s through the early 2000s, when that last set of aerial photos were from. You can see most of the time, so every little blip here, all these are showing you the volume of sediment that was input in that year and at that place. Most of the time in these areas, there's not a lot going on. It's a pretty calm climate. We get waves, but sand gets moved offshore and then brought back on. There's just a few of these years in here where it's really stormy and there's a lot going on, and or a few places where there's a lot of sediment. So overall, kind of the findings of this study were that there's not really a lot of long-term erosion happening. It's more that it's shifting. So if you look here from 1945 to 55, it's mostly getting wider. And then there's a little of both, a little of both. But a lot of these years, this is the beach getting wider, the beach getting narrower, the beach getting wider in all of these different places. It's kind of shifting back and forth with the climate and with the climate cycles. So that was interesting for people to see because it was different than what people had originally thought. So that's what I spent 4 years of my life studying while I was at UC Santa Cruz. And I'll say that while this is really interesting to me and I get really excited about it, I came to a point where I really wanted to work on things that I felt like affected more people and had more of a benefit for more people. So as soon as I finished with my PhD, I started teaching, but I also did work on the side looking at hydrology and mostly water quality. So I tried to find a more flattering picture of myself, but unfortunately most of this work gets done in the rain and there's no good pictures. But I did a lot of work in the San Mateo County area looking at stream flow. So this is measuring stream flow. So I've got this little cone shaped thing in the water and it goes around and you count how many times it goes around and that tells you how much flow there is based on the cross section of the stream. So again, very low tech. This is at low flow, but when it's high flow, we do things like throw a leaf in or throw a stick in and measure, count how many seconds it takes it to get from point A to point B to quantify the flow. So I've done a lot of work like that. And this is looking at water quality. When it rains, all of the pollution that goes onto the streets runs off into the water supply, and that affects the organisms that live in it. It affects the water quality. So this was in, I want to say Menlo Park or somewhere in the peninsula, one really stormy Saturday evening, measuring water quality from a storm drain. So maybe it doesn't sound glamorous, but it's really fun work. And I've been lucky that I've been able to take students on some of this and have them get paid internships doing some of this work. I also did a big study a few years ago now, but this is Pillar Point Harbor, so just south of us. And there was some microbial pollution, so microbes in the water that were making people sick. And the question was, where were they coming from? There's a lot of birds in the area, so it could be bird poop. There's a lot of people who walk dogs, so it could be waste from the dogs. And there's also houseboats and trailers that were parked in the area. So the Peninsula Open Space Trust was interested in finding out where this pollution was coming from. So they had me do a circulation study. And so all these little symbols that you're seeing here are buoys that I set up with a team of folks where we took samples over the course of like 3 days. So what we did, and I know it looks bad, but it's not, there's very minimal, almost non-existent environmental impact to these dyes that we put in, but they're these fluorescent dyes that we dumped in the water in 4 different locations. And then over the course of 3 days, had people taking samples at each of those points throughout the harbor to see how the water circulated, to understand where the pollution was coming from and where it was moving to. So this was a really cool project that was able to benefit the local people by trying to understand and then minimize the sources of pollution to the water. So that's kind of the work I've done in the field of geology. And then I just want to talk a little bit more about some of the things that I've done at Skyline. And this is, well, not quite yet, but we're about to veer away from geology. So I started teaching at Skyline in 2014. I was super excited to come here because we have a lot of really great programs, really innovative programs, and we do a lot of work around sustainability. And we're in a beautiful location. And I'm not going to lie, that was one of the main reasons why I left the job that I was at and came to Skyline. Because as a geologist, being able to walk out the door and look at the ocean or look at the beach, see the San Andreas Fault is really exciting. But these are just some pictures of students and some of the work that we've done. The students here are doing a lighting audit in one of the classrooms. So measuring the lighting and seeing if we're using more energy than we need to be to light our classrooms. This is another water quality study. These are both in San Francisco, looking at just the geology and then the geologic and climate history. And then this was a waste audit that we did a couple of years ago, which sounds gross, and it is, but it's also really cool. We had facilities save all of the garbage from building 6 over a 24-hour period, and we took it out here and dumped it out, and the students sorted through it and saw how much waste we had and how much of it was being put in the wrong bin. So we have compost, recycling, and garbage. And so we were looking at how much of what was in the garbage could actually go in the compost, for example. And the students were not super excited about it at first, but then were really impressed by what they were able to see. And one of the students found a whole pancake breakfast, like 2 huge pancakes. And he just talked about that the rest of the semester, like being horrified by how much waste they were able to see. So one of the things that I'm looking forward to is getting back on campus and being able to do some of this work again. And another cool program that we have is Energized Colleges. So this is kind of a shameless plug because we still have it and we're still recruiting interns for it, but these are paid internships. I was a faculty coordinator for it when I was faculty, and now we have a sustainability coordinator who's running it, but it's a great opportunity for students to get exposure to green workforce careers, and also for campuses to create energy savings. So I'll just flip, well, let me talk through these really fast. So experience professional development. All the students do talks, they create posters, and then some of them are with community partners. So just going through pictures from some of the projects that we've had, you might recognize some people in here, but we are able to fund about 10 students to have these internships every year. And the things that the students say after the fact, they talk about how much they've learned about sustainability and environmental careers, but then also the professional development that they get, getting practice making posters, getting practice sending professional emails, practice creating a resume. All of that is really beneficial. And I highly encourage all of the students who are on here today to seek out any of those opportunities that you can. If you're interested in this program, let me know. We've had a lot of students who are not environmental science or any kind of earth science major, and we're really looking for diversity in terms of backgrounds. So that's a great opportunity. And it's fun to look at these pictures. And so then from that, I moved into the meta majors and guided pathways work. I'll talk about this really quickly, but again, if you don't know about it, it's all to benefit students, to help students to choose a major more quickly, to learn what opportunities exist for you along the way, and then to graduate and transfer or get a job as quickly as possible. So at Skyline, we have 4 different meta majors, and our science, technology, and health meta major includes all of the STEM fields and includes automotive, kinesiology, and a lot of our really bigger programs on campus. So the that leads me to, I guess, and I think I was going to say something else about that, but I forgot what it was. That leads me to my current role, which is as the Dean of STEM. And so I think kind of the point that I wanted to reemphasize here is that I have no training for this job or for the previous job that I did as the Director of Guided Pathways. So I'm a geologist by trade, and that's what I always tell people when they ask me a question that I don't know the answer to. I tell them, well, I have a PhD in geology. But I think the thing that I want to share with you all is that you figure it out. So once you find something that's of interest to you and you do it and you do the next thing, you're always learning and you're always gaining new skills and you're always getting exposure to new opportunities. And I've been in this position for 6 months now, actually more than that, since June of last year, so about 8 months. And for the first 6 months, I was exhausted every single night because of all of the things that I was learning each day. And so I think that it's really important to do that and to push yourself, but then also not to feel like you have to have the training. So a lot of people who do these kind of educational leadership roles, deans or vice presidents or presidents of colleges, have a doctor in education. And but you don't have to. Like, you can learn these things as you go and you can pick up the skills along the way. So don't ever feel limited by not having the exact degree, and don't ever feel limited in terms of choosing a discipline or a degree that you want to go into because you think you're locked into it, because you can always move in a different direction. So just a little bit about our division, and then I'll stop because I need to allow time for questions. But we have, if you look at all of the programs that we have about 20 different programs, and they're very varied. So we've got all the allied health programs, which will lead you directly into a career. And then we have the transfer-oriented programs like physics and math and chemistry and biology. So there's a lot of different opportunities in our division. We have the largest division on campus. We have about 37% of the student population at any given time is within our division. So we have over a third of the people, both in terms of faculty and also in terms of students in our area. We also have really great resources like the STEM Center and the Fab Lab and the Energized Colleges internships that I was talking about a minute ago. So we have a lot of great opportunities for students. And I will say, having taught at other community colleges, Skyline is a great place in terms of the size and being able to have access to resources and all of the resources that we have. So I encourage you all to take advantage of those while you're here. So just in closing, I'm back to geology pictures now, but just a few parting words of wisdom that I want to leave you with. So my recommendations to you, and these are the things that I always tell students when they come and talk to me. Talk to people who do what you are interested in doing. Even if you don't know exactly what you want to do, talk to people who do something similar. Find out what they do. People like to feel important. And if you ask them questions about their job or their experience, they're going to feel important and they're going to want to help you. And even if they're not doing exactly what you want to do, they might know somebody who is, or they might give you a foot in the door to help you meet somebody who is doing exactly what you want to do. Go to conferences where people are talking about things that are of interest to you. And now is a great time for that because we're not traveling. All the conferences are online. And so they're a lot cheaper. Even during normal times when they're more expensive, there's always scholarships for students. They will often let students sign up to volunteer, and then they'll waive the admission price, the registration price. So do that if you can. We have scholarships in the division and in the college for students to be able to do things like that. And we often take groups of students. So if you have those opportunities and you can take advantage of them, I will say that I am an extreme introvert. I don't like to talk to strangers. And every time I go to conferences, and the whole time I was in grad school and advancing throughout my career, I would go to conferences and I would force myself to talk to people, even though I really didn't want to do it, because that networking is the most powerful thing you can do in terms of finding a job. Get any experience that you can. Sometimes I will offer students an internship or an opportunity in something, and they'll be like, no, that's not exactly what I want to do. Even if it's not exactly what you want to do, any opportunity is a good opportunity. I did a lot of things along the way that weren't exactly what I wanted to do, but they all helped me to gain skills, and they all helped me to put things on my resume that helped me to get jobs that I did want to do. So if you can take an unpaid internship, um, and that's a tough one, but if you can take one and work on another job on the side to be able to pay the bills, whatever you can do to get experience is super important. Apply for opportunities even if you think you won't get them. So if you see a grant or you see a scholarship, apply for all the scholarships. The worst they can do is tell you no, and more times than not, they'll tell you yes, and you'll get free money and be able to do things. So look for all of those opportunities and don't turn them down. And then talk to people. So again, that's the most important one. Getting to know people is the way that you get opportunities. And the more people in the more varied positions, the better. So that's all I have to talk about. And I know Brian has been fielding the questions, but I also wanted to say if there's any things that you all want to share with me about what you would like to see in the STEM division, you can ask them now, or you can feel free to email me anytime. I'm always happy to set up a Zoom to talk with folks and kind of hear your thoughts. So I will open it up to questions now.
Thank you so much, Carla, for sharing with us your research, your journey, and then also some of the work, exciting work that you're doing at Skyline College. So I've been fielding all the questions that have appeared in the chat, either through a direct message to me or to everyone involved in the chat. But I wanted to start off just kind of chronologically. So starting off with the introduction, one from Professor Wamba, is geophysics part of what you study, or is that considered a separate field?
Geophysics is not what I study, but I did definitely go to grad school with geophysicists and know some, but no, that's never been my field of study.
Okay. One follow-up question to that is, since you do coastal geology, is that in any way related to marine biology?
It's not really too much. I will say that that's kind of one of the earlier things that brought me into this field, as I was really interested in marine biology. But no, it's pretty distinct. There's some overlaps in places where we're talking about where there is sensitive habitat and how the sediment and the movement of sediment can affect it. But no, they're pretty different. And normally you would have a biology degree to study marine biology. There is biological oceanography, which is kind of different because it's not looking at the organism so much, but the interactions of all of the the different components of the ocean.
Okay. And so kind of a follow-up question to the topic of coastal geology. This one, getting straight to it. Why did you choose coastal geology?
So I started out as an environmental science major. I should have said this. I started out as an environmental science major and I hated biology. So my apologies to the biologists in the room, but I hated biology. And so I really loved that same semester, I was taking a geology class and I loved geology. And I was really interested in oceanography and geology. And so the coastal geology is where those two things meet. And so that's kind of how I got interested in it.
Okay. And so a follow-up question to your personal choice, why you chose coastal geology. We have a student asking just a more generalized advice, kind of piggybacking off of your last slide, right? Do you have any advice for STEM students in choosing the field that they're going to take?
I think things like this, where you can get a wide assortment of exposure to different topics and kind of seeing which ones resonate with you. It's always going to be hard, no matter what field you go into, it's going to be hard. So just finding the one where where you feel passionate and you're like, I just want to know more about that is really the thing to do. And again, just talking to as many people as you can about what they do and what they love about it and what they wish they had known when they went into the field, or what advice they have to share, I think can really help you with figuring out which path you want to go. And then also just thinking about like, what type of job do you want to have? Like, I really wanted to work outside and I really wanted to travel, and geologists get to do both of those things. And so that was now I don't do either at the moment, but that was one of the things, or two of the things that really brought me to geology. So just kind of understanding the type of environment or the type of job you want to have and doing research around that.
Okay. So this is another question that came up in the chat that I think kind of follows pretty nicely. And it's in relation to the ability to travel and the ability to go around. And so, simple question: what would you say is your favorite spot to go to visit as part of your research, and maybe a little why?
Oh my goodness. So that's a really hard one to answer. I would say probably if we're talking about like places I've done research or worked, I think probably two top spots. One is Scotland, which is the birthplace of geology. Like, all of the early geologists and all of the earliest discoveries in geology were made in Scotland. A bunch of old dudes and during the Renaissance time were going out. They had a lot of time on their hands. They were looking at how things changed, and they made a lot of these really big scientific discoveries. So that's an amazing place just from a kind of geology and historical perspective. In terms of doing work, the Oregon coast was probably the place that I've enjoyed doing research and working the most, because the coast is just so wild. It's different from our coast. It has a different geologic setting. So it has a lot more of the volcanic rock, which make it really dramatic.
Thank you. Thank you. So this one's a little bit specific to your research. And you spoke a little bit about it throughout, but I guess I'll just pose the question directly. What are some tools, techniques that you really use to test the quality of the water?
So that's interesting, because I will say that most of the water, the actual testing of it, I didn't do myself. I did the sampling, and then it gets sent off to a lab that's like a clean lab, where they actually measure the chemicals in it. Some of it we would dehydrate, cook it in an oven, and sort it. But that was mostly for sediment grain size. You need a more specific facility to be able to test both the microbes and or the chemical components. And a lot of what we're looking for, that picture that I showed with me rain drenched, that was looking for heavy metals that were running off from the road. So I can't actually answer that question because I didn't actually do the part, just taking the samples of the water.
Okay. Thank you. Thank you. I want to transition the theme of the questions a little bit here in terms of, in a way, a call to action. So one student asks directly, any advice on how we can get involved in coastal conservancy or any agencies that students can volunteer for? Any recommendations there?
Yes. So lots of recommendations. And if you want to send me an email in particular, I can follow up with even more recommendations. But around here, the Pacifica Beach Conservancy, PBC, I can get you the name. They do beach cleanups every weekend. We've done a lot of them with students from Skyline. We've done our day of action where we've taken a group of students out to the beach and done beach cleanups. So they do those every weekend in different locations. A lot of the different parks conservancies. So there's one in San Francisco, there's one in San Mateo County. They're not the county parks themselves, but they're like a nonprofit that works with it. They do habitat restorations and cleanups along the various parks. There's a lot of other organizations which I'm blanking on the names of right now, but those are a good start. And one of the important things that I will say is, or one of the biggest things that I think you can do is just educating people. So like a lot of the work that we do when we go out and do a beach cleanup is picking up cigarette butts. And the different organizations actually get money for however many cigarette butts they're able to collect, because they're not only garbage, but they're actually toxic. So the chemicals that the filter is soaked in are actually toxic to the organisms. And so they do a lot of work collecting those. So even just knowing that and telling people not to throw their cigarette butts on the ground, that is helping a lot. That's one of my biggest pet peeves. But also the thing that as an individual you can do to, yes, thank you, Emily, Pacifica Beach Coalition. One of the things that you can do to have an impact. And we are trying to get a group together for Earth Day to go out and do a beach cleanup. So if people are interested in that, let me know, and we can try and do a larger campus event.
Thank you. Thank you. Thank you. One follow-up question to your data slides back when we were describing El Nino and La Nina. Just out of curiosity, where does the ocean temperature data come from?
It comes from satellite images. A lot of it comes from satellite images. Some of it comes from buoys that are out in the ocean actually collecting data in the oceans, but there's only a few of those scattered around, and so most of it comes from satellites.
Okay, thank you. So with the time that we have left, I'm going to transition it slightly over to more Skyline relevant questions. And so going back to the internships. So the question directly, hi, Carla, what did the paid internships you mentioned involve for the hydrology consulting projects you mentioned? And how long would that internship take? Really curious student.
So those internships involve, it's called storm duty. That the picture of me rain drenched is because it was raining really hard one day and they needed to do samples. And so they called me and said, hey, can you come do samples? And the same thing, we've got, at that time we had several students signed up. And so they would call them on the day of and say, hey, this was a hydrology, Balance Hydraulics is a company that I worked with in Berkeley. And so it's just a one-off or, on-call type of situation in terms of being able to do the research. But the thing is that it's only in need when it's raining a lot. So this winter, we haven't done any work because it hasn't been raining that much. So it's really only on those El Nino winters when we're getting lots of rain. But that's something, if you want to keep in touch with me, I can keep your name and let you know the next time we need people.
And then one other follow-up question from a student: are there any opportunities for the environmental internships through the school at this time?
Yes. So we have a couple that we're interviewing for right now. One of them is, let's see, I know the ones that are already hired. So we've got a couple. Emily, who's here, is working with the transportation intern. We've got a couple who are doing a podcast and sustainability. We're hiring one. One of the things that we're doing is trying to create a set of courses from all different disciplines that are taught around sustainability. So like an English course that has a sustainability theme, or a physics course that has a sustainability theme. So we're hiring an intern to work on that project. And then there's one other that we're hiring right now that I cannot remember what it is. But again, if anybody wants to send me an email, I would be happy to put you in contact and give you more information about that. And we do that every year. We have funding that's now institutionalized from the college. So every year we work to identify projects that we think need to happen and hire students to do those projects.
Thank you. Thank you. Actually, we have one other question. Going back to your research, actually, just out of curiosity. So we when we looked at the Pillar Point pollution, we observed how it was being studied. But just out of curiosity, what ended up being that cause of that pollution at Pillar Point?
It was not as clear cut as we might have wanted. So there's two different, let me see if I can put this back up here really fast. Are you seeing this, or did I did not share my screen? Okay, let me just talk about it. There were two different kind of main sources. So there was an area where there were a lot of people camping kind of over in this area, and then areas where people were like walking dogs and stuff. And so most of the pollution was coming from this area, but it wasn't necessarily all from one source. So there were some microbiologists from UC Davis who looked at the pathogens as well as me looking at the circulation. And so the pathogens were coming from several different sources, but mostly in this area.
One final question. In the interest of time, we're just hitting 5:30. And this just came into the chat. How do you find jobs with such a specific field? You mentioned that some aspects can only happen during certain times of the year. So what can you do when there's really nothing to do?
Well, if you're talking about like a long-term job, there's still work for hydrologists at all different times of the year. So some of it is looking at how the streams flow normally. Anytime anybody wants to build a house or do anything in the coastal zone or anywhere really, they need a geologist or a hydrologist to look at it and to say whether it's safe to build there, how it's going to affect the water, how it's going to affect sediment transport. So there's always work to be done. Again, it kind of, I think, goes back to the idea of the more people you know, the more opportunities you have that will come up. So some of these things are seasonal and there's more work to be done in certain seasons than others. But if you kind of piece together the things in different seasons, it makes an actual career.
All right. So in the interest of time, I'm going to go ahead and close it out here. Carla, thank you again for spending your time with us this afternoon/evening. sharing your research, your educational journey, and all the work that we have you doing at Skyline. Thank you.
Well, thank you all.